My name is Mohit Chabda, and in today's video we will discuss about binary search. It's a very important concept which is frequently asked in the tech interviews. So watch the video till the end. Let's start with the problem statement. We are given an array of integers named nums which is already sorted in ascending order. Apart from this, we are also given an integer named as target. We need to write a function to search the target in the nums. In case target exists in the nums array, we need to return the index of target. Otherwise, we need to return -1. Now let's move to the visual representation to understand it more clearly. Here in this example, you can see we are given nums integer array, and apart from that, we are also given target. So in the visual form, it would appear something like this. So this is the integer array, and we have also written the indexes. So we need to search target, which is 9 in this array. Now the brute force to solve this would be linear search. That is, you will traverse the complete array one by one. So you will start from here, you will check -1, is it equal to 9? No. So you will move to the next element. So you come here to the index 1. You will again check whether 0 is equal to 9. No. So you will move ahead, increment by 1. So you go to the index 2, check the value at index 2, which is 3. Is it equal to 9? No. You move to the next index, which is 3, and the value present is 5, which is not equal to 9. You move to the next element, which is index 4. The element's value is 9. Here 9 is equal to 9. So we found a match, and hence we can simply return 4 because we need to return the index where we get the target value. So at index 4 we found the target value. So you can see in this approach we traversed each element of the array one by one. So basically this was linear search, and in worst case, if there are n elements in the array, the time complexity would be O of n, where n is the number of elements in the array. The code for this linear brute force is very simple. We just need to make a loop and traverse through each element and check that with the target. Let's go to the Leetcode and write the logic for this simple approach. So let's first of all write the code for linear search, after which we will understand the concepts of binary search. For linear search, simply apply a loop for int I equal to 0, I is smaller than nums.length I plus plus, and then you will simply check if the element is equal to the target. Like if nums of I equal to target, you simply return the index. So index is element I, so you return I. So once you are out of this loop, in case you haven't returned anything, you will have to return -1 because that's mentioned in the question. So this is a very simplified kind of approach that we applied. Let's try to run this. A basic test cases are passing, and let's now try to submit it. You can see all of our test cases are passing, but we are just beating 10.14%, which is quite low. Talking about the time complexity, as we have traversed the complete array using the for loop, so if there are n elements in the array, the time complexity would be O of n in the worst case. Let's see if we are correct or not. You can see here it's O of n, it's linear time, and hence this searching approach is also called linear search. Talking about the space complexity, we did not use anything else apart from the variable, which is considered as a constant space, so it will be O of 1 as a space complexity. Now in the question it was already mentioned that we need to solve this problem in O log n complexity, whereas we just solved it right now with O of n time complexity, which is wrong. So let's try to solve this problem in a better way. Let's go back to the visual representation. Alright, we are back here to the visual representation. You know that we applied the linear search here, but we did not utilize one of the properties which was already mentioned in the question, which was that the array is already sorted. So you can see here this array is already sorted. Can we use this property to reduce the time complexity? Yes, we can use binary search for this. You use binary search in day-to-day life by default. For example, you have a dictionary. So in the dictionary, you already know that the words are in the sorted order. Like in the first page you see A, then after that you have B, then C, then D. So all the words which are starting with A would be in the starting of the dictionary, whereas all the words starting with Z or Z would be at the end of the dictionary. So you already know this. In case you have to search for zebra in the dictionary, you won't start it from the beginning, correct? You would simply go to the end of the dictionary where Z starts, and then you also know the next alphabet is E. So you won't start from ZA, you would simply go to ZE, right? Because you know that all the words in the dictionary are in the sorted order. So in the similar way, we use the binary search instead of the linear search. If in order to search for zebra you start from the beginning of the dictionary, that's a linear search, which is a waste of time. What you can do is apply a binary search. What happens in the binary search is we always take a middle element. So you have the start, you have the end, and you have the middle element based on the start and end. On the middle element, you check whether it matches the target or not. If in case it matches with the target, wonderful, you simply return the index and your program ends there. But in case your middle element doesn't match with the target, then you will simply see whether the middle element is greater than target or smaller than target. Let's understand this with an example. So in this case, we have the starting index as 0 and ending index as 5. So you will do like start, end, and middle element. So start is 0 because the array always starts with 0 index. The end would be 5, so you put end as 5 here. The end may vary based on the number of elements in the array. In this case, we had only 6 elements in the array, so the ending index means the last index would be 5, so we have kept it as 5. What would be the value of m, that is the middle element? Middle can be s plus e complete of this sum divided by 2. This can give you the middle element, but there is one issue in this approach. You know that integer has a limit, right? Say for example, this array is a very big array, so the size of the array can be the integer maximum limit, correct? So if you do s plus e, where e might be the maximum value of integer, if you're adding something to that, it would cross the limit of integer, so it can create issues, right? So the better approach to calculate middle element is actually m equal to s plus, so you will do e minus s divided by 2. So this will also give you the middle element. The good part is, even if e is very large, it can be very near to the last number of the range of integer, but then you are subtracting s from it, so by default it won't cross the limit of integer. Hence this is better than this one. So in case your array is very large, this concept can give you issues, whereas this one is much better. So we will calculate the middle element using this approach. So in this case, we had the start as 0, so we'll do 0 plus e is 5 minus 0 divided by 2. So 5 divided by 2, because we are doing integer, so it will return you 2. So 0 plus 2, so middle element will come as 2 here. So at the second index, which is this one, you will simply check whether the element is equal to the target. The element present is 3, whereas the target is 9, so these are not equal, right? So now you need to check whether the current element is smaller than the target or greater than the target. Here you can see this 3 is smaller than 9, right? So what should we do in this case? It's very simple, that now because your array is already sorted, so now we need to go ahead of this, right? Because you need a value which is more than 3. You don't want to go back now, because the elements on the left side would be smaller than 3. You want to have some value which is more than 3, so you want to go to the right side. What you will do is like make the s, that is the start, as middle plus 1, because you want to go ahead. So now your start, instead of being here, it won't stay here, it will become this one, that is middle plus 1. So now your start is index 3, end is index 5 only, so this will change. Instead of 0, you will make it as 3, and the end will stay same, okay, 5. So now again you will calculate the middle element in the similar way. That would be start, that is 3, plus your end, that is 5, minus 3 divided by 2. So this will become 3 plus 2 by 2, which is 1, so it will become 4. so your middle element becomes 4 here. So there might be some doubts in your mind, why did we change the start and not the end? That is because the current middle element was smaller than the target. That is, whatever we wanted, we currently had the value lesser than that. We wanted a bigger value than that, so you would move to the right side because it's a sorted array. So the elements on the right side would be of higher value, which we actually want. So what we want to do is, the starting element, we want to move it on the right side. Okay, in case our element would have been larger than the target, then we want it to go on the left side. In that case, we won't modify the starting element, we would decrease the ending element. So the ending element would become middle minus 1. We will see that in another example. For now, you can see the middle has become index 4. So at the middle element, we will calculate if 9 is equal to 9, where we have found a match. So what we will do is simply return this. Let's take another example to understand this in a better way. You could see here, now we have a different example. We have the nums integer array, we have the target value, which is different now. In this array, we need to find this target. So we will follow the same approach that we just discussed, that start, end and middle element, and this approach as well. So I'll simply rewrite this kind of stuff here. You will have the start element, you will have the middle element, and you will have the end element. So the middle logic would be, you would do middle equal to start plus you would do end minus start divided by 2. So using this, you will calculate the middle element. Okay, so in the beginning, your start will be 0, which will be the start of the array. So this will be the start. Okay, your end will be the last index of your array, which is 5 here. So I'll make end as 5. What will be the middle element? M is equal to 0 plus 5 minus 0 divided by 2. So 5 divided by 2 would return you 2, because integer by integer gives you integer. So 0 plus 2 gives you 2. So you have your middle element as this one. Okay, now you will try to check this value with the target. So nums of m, you have value 3, whereas your target is 2. Now your middle element is actually greater than the target value, which is the other case of the last example which we saw, correct? So in this case, your value is greater than what we want. Where will you go? On the right side? Not at all. If you go to the right hand side, you will get bigger elements which have greater value. So you want to move to the left side of it, right? So now in this case, we won't change the starting element, we would change the ending index. Okay, so in this case, because your current middle element value is greater than what you want, you will make your ending index to middle minus 1. So your middle element was 2, so in this case your ending element will become 1. So I'll make it ending element as 1, starting will remain same as 0, and middle will become, same logic you will apply on this one, 0 plus 1 minus 0 divided by 2. So 1 divided by 2 is 0.5, but because integer by integer gives you integer, so it will return you 0. So 0 plus 0 gives you 0. So middle element is also 0. So starting index is 0, ending index is 1, and middle index is also 0. So you will check the value at middle element. So minus 1, compare this value with the target, which is 2. Now minus 1 is smaller than 2. So your middle element is smaller than what you actually want. Now what you want to do? You want to go to the right side, because it's a sorted array. On the right side, you will get the higher values. Here you want a higher value because minus 1 is smaller than 2. So you want to move to the right side. So what you will do is make the starting index as m plus 1. So middle element was 0, so you want to update your starting index starting index will become 0 plus 1, that is 1. Okay, the ending index will stay there. So starting index is also 1, ending index is also 1. So in this case, what will be the value of middle index? Middle will become start, that is 1, plus end minus start, which is 1 minus 1 divided by 2, which is 0 by 2, which is 0. So 1 plus 0 is 1. So your middle index will be 1 as well. So all three of your values, start, end and middle, all three would be at index 1 here. Okay, so at index 1 you have value 0, at target is 2. Okay, so 0 is smaller than 2 again, so you want to move to the right side. Again, what you will do is like you will make start as middle plus 1, so your starting index will become this plus 1, so your starting will become 1 plus 1, that is 2. Your index will stay the same, which is 1. Now there is a problem because your starting index has become more than your ending index, and that is not correct. So your loop will stop here. Okay, and hence you didn't find your target and you will simply return -1. Okay, you can see here, correct, 2 is not present in this array, so we will return -1 for this. So the main logic is, in case you find the element, you simply return that index. Okay, in case the element present at the middle index is smaller to the target, you would like to move to the right side. So what you will do in that case, s equal to m plus 1, because you want to move to the right side. So your end index will remain the same. You will simply increase your starting index because you want to move to the right side. But in case your value present at the middle index is smaller than the target, then you want to move to the left side. Okay, left side of the array. In that case, you want to keep your starting index as same. You just want to decrease your ending index, which will become middle -1. Okay, so basically you are coming to the left side of the current value. So if I write the basic pseudo code for this, it would be something like, if nums of m, that is the middle element, equal to target, then you simply return the I, that is the index. You simply return the index. Okay, other case would be if your nums middle element is greater than target. Now I haven't applied else if here because you have already written the return statement. When you are writing the return statement, your method would be complete, so there is no need to write the else here. So you can simply write if condition. Okay, so in this case, what you want to do, you simply want to go to the left side because your current element is greater than what you want. So you want to move to the left side because your array is sorted, and on the left side the values would be lesser. So in this case, you want to keep your starting index same, but you want to make your end as middle -1. Okay, and in the else case, I have written the else here because this case is already covered. So equal case is already covered. Then we have written the greater than case, and the else case would become less than, that is the nums of middle element is smaller than the target. In that case, you won't change your ending index. You just want to move to the right side because you want to increase your value. So you will do start equal to middle plus 1. So this is the simple logic that we need to apply. These 3 lines of code will decide where your index will move, and this is the logic of binary search, which we can apply only if your array is sorted. You need to remember, we can apply this kind of logic if your array is sorted, otherwise you won't be able to apply binary search. Okay, but in this question we were given that the array is already sorted, so we will apply binary search. Now let's move to the Leetcode and write this logic properly and see if our test cases are running and find out the time complexity. So we are back at Leetcode. You can see we already wrote the code for the linear search, which was brute force, for which the time complexity was O of n. Let me reset this code so that I can write the code for binary search. So for binary search, as we saw in the visual representation, we want the starting index, ending index and a middle index. So let me create these indexes. Start equal to 0, end equal to nums dot length -1, because the indexes in array start from 0 and they are till the length -1. And apart from this, you will also have the middle element, which in the beginning we can set as 0. Okay, so you simply write a loop. I can simply write a while loop while your start is smaller equal to end. Okay, we will keep this loop running till your start is smaller equal to end, and in case you find the element, you will simply return, so your method will return from there. Okay, now we have to write this logic, but before that we need to calculate the middle element, and the middle element logic is this one that we just discussed. Middle element equals start plus end minus start divided by 2. So we'll apply this same logic there. You'll do middle equal to start plus end minus start divided by 2. Okay, so via this you'll get your middle element. Now you need to check whether your middle element is equal to target or not, which we just checked in this visual representation. These 3 lines of code we need to write. First we check if the nums of m equal to target. We do the same thing here. If the nums of middle is equal to target, so in this case you simply return the middle element index. You need to return the index, that's why we are returning middle instead of nums of middle. Nums of middle would contain the element, we need to return the index. So in case we found out our target element in the array, we simply return the index. Okay, so let's talk about the other cases which we discussed here, right? In case it's equal, we simply return, but in case your nums of middle element is greater than target, then you don't want to move to the right side because your current value is greater than what you want. Here if you go to the right side, these values will be larger. You want a smaller value, so you want to move to the left side. Okay, so your starting element will stay the same, but your ending will change from here to here. So middle -1, correct, what we did here. So same logic will apply here. If your nums of middle is greater than target, in this case what you will do simply is your end equal to middle -1. Okay, because at the middle you didn't get the value, so you want to make your end before the middle. Okay, your value would be before the middle only, so your start remains the same. You decrease the index value of the end. Instead of being at the end, it makes middle -1. So now your range has decreased to only this part. Okay, and then you write the else case, which simply means that your nums of middle is smaller than the target, and in that case you would want to go to the right side because you want bigger values, and in that case you keep your ending as same. You change your start to middle +1, so that you need to check in this range. Okay, this part that we did, and we need to write the same logic here. Your start equal to middle +1. Okay, you write this kind of logic, and now say this loop has ended because your start is now greater than end, but you haven't returned this. So in that case it means that that particular element is not present in the array, so you simply write return -1. Okay, so this is basic binary search that we applied. We haven't checked each and every element here. We are simply using the middle element to find our target values. This is binary search, and you will see a lot of applications of binary search in various questions. If you understand the basic of binary search, you can solve a lot of questions very quickly. You need to remind a very simple thing: if your array is sorted, then in your mind binary search should always come. If it's sorted, binary search. Okay, remember this thing. Now let's try to run and check if our test cases are passing or not. Our basic test cases are passing. Now let's submit and check if everything is passing, all the test cases. You can see here all the test cases are passing, and it says beats 100%. Oh wow, that's amazing. Earlier we were just at 10.4%, I think. Now it's like 100%. So it's a brilliant and amazing solution that we have written. Talking about the time complexity, last time when we did the linear search, it was O of n because we were traversing through all the elements. But in this case, the time complexity is a tricky part. Let's go to the visual representation and check once again. So say for example, this is your array. We are always going to the middle element. So this is start, this is end, and this will become the middle. So middle of the array. In case you find the element, you will simply return the middle element. But in case you don't find the middle element, say your middle element is greater than the target, then what you will do, you'll go to the left side. Okay, so you can see we have divided the array in two parts. Now we will simply ignore the right side, we'll simply traverse to the left side. Your end index will become middle -1, so end will become this. So you have only this set. Again, you will distribute it in two parts because you have the middle element. Either you will be on the left side or the right side. So one of the things will be removed. Again half, again half, again half. So using this, you're always dividing your array in two halves. Okay, and you are taking one half and completely ignoring the other half. So the time complexity of this will be log of n, where n is the number of elements, but the base will be 2. So log base 2n. Why 2? Because we are dividing the array always in two halves. Okay, so let's check if we are correct in this case. Let's see the time complexity. It should be log of n. You can see log of n. So we have now improved our time complexity. Instead of O of n, we have solved this question in log of n. What about the space complexity? We have simply used the variables here, nothing else, and variables are considered as a constant space, so hence the space complexity will be O of n. Let's see. You can see we have solved this problem in constant space complexity, and the time complexity is very less as well. In the description it was mentioned we need to solve this in log of n, which we have done. So this was the binary search. I hope you understood the logic. I would request you that you solve it on the paper and pen, drill down all the cases, try to understand what we did. We are simply dividing the array in two halves, always ignoring one of the half completely and picking another half. Try to understand this logic similar to what you do in dictionary. Say for example, you have to search a word starting with M. You generally start with the middle of the dictionary, right? You won't start from the start, you won't start from the end, you'll check the middle. So in the binary search as well, we always go with the middle element. Okay, so in this way we have reduced the complexity, but you need to remember binary search is when your array is sorted. Okay, remember this. Whenever your array is sorted, it should trigger in your mind binary search. Okay, in case you have any doubts, mention those in the comment section. All right then, this is Mohit Chabda signing off. Subscribe to the channel and thanks for watching.